Okay, I'm going to work on this problem that's it's a pre-calc level problem that one of my students was having difficulty with. The subject here is just functions. There's a little trigonometry involved. So we're given this function y equals 2x squared plus 1, and we're given an interval on the x-axis from 0 to 2. So we'll call this as our 2. The function here is going to cross the y-axis at 1, right, because when x is 0, this is just 1. So we're going to have this point right here is on the curve. And so this is a parabola, right, so it's going to look something like this. And so the point, this point here, 2 corresponds to what? You take 2 squared, that's 4 times 2, which is 8, plus 1 is 9, so you have this point here, 2, 9. And so this is kind of going to be like the last point corresponding to this interval, and so the first point corresponding to this interval is right there at 0, 1. Okay. Now, we're going to use this point 2 here as a sort of pivot point. And so we're going to imagine from this pivot point lines drawn to the curve. So starting at the pivot point, so you could have a line being drawn to the curve like that, like this, right? Something like that. And it's going to make some angle with respect to the x-axis. And of course, there's an infinite number of them. That's why I'm saying this is a pivot point, because we could have another one coming up here, and it's also going to make some angle with respect to the x-axis. The smallest angle is going to correspond to this here, right? Because we end at 0. So the last line that we draw to the pivot point on this end here is going to have the smallest angle, and then the largest angle is going to correspond to this line, and so that's going to be just a 90-degree angle. And so what's the object of the problem here? Well, we want to find a function that will give us the angle that any given one of these lines will make with respect to the x-axis as a function of x. And so basically, if I were to take, let's say I pick a point somewhere on this interval from 0 to 2, say I pick x equals 1 here. I could draw a line up to the curve from x equals 1, and then draw another line from that point back to the pivot point. And then this line that goes back to the pivot point is going to make some angle with respect to the x-axis, and so we're looking for a function that will give us this angle for a given value of x. So I can plug in what my x is, and it will tell me what that angle would have to be for any given value of x on this interval. Okay. And so it seems a little intimidating at first, so it's not as bad as you think. So first of all, realize that each one of these points is going to have the form x comma 2x squared plus 1, right? Those are your ordered pairs. And so we want to relate the sides of this triangle to the angle here first. That's the first step, obviously. And so we might choose to write the sine of that angle, just an arbitrary angle for one of these triangles. Okay, so this is just like an arbitrary triangle. Obviously, there's infinitely many of them, but we're just going to write down equations that apply to every one of them by just staying in terms of x. And so first, so what is the sine? Well, it's going to be the side that's opposite the angle, so that's this side here. Call that the opposite side, over the hypotenuse, which is this line here. So notice that the side opposite here, I mean, this is just going to be your y coordinate, right? That's just your point along here. Okay, so the opposite And so really, I mean, both of these here, so this is, I forgot to fill that in, this is, the sine of that angle is going to be the opposite over the hypotenuse. And these are really just going to both be functions of x's, right? And so the opposite as a function of x is just the y coordinate, which is 2x squared plus 1. And so my student was having a hard time understanding that. I mean, just remember what you're doing when you plot points, right? So if you plot a point, like let's say you're plotting 2, 3 or something, I mean, you just move over 2 on the x-axis, 1, 2, and then you move up 3, 1, 2, 3. And then you plot the point. And so the point here is 2, 3. And if you were to draw lines like this line would have a length of 2, and this line would have a length of 3. Okay, and so here this is a little more abstract. We're writing the points in sort of this general form, so it can correspond to any value of x. But, so if this were, say, x equal 1, say right here, if I were doing that specific point, this would be 1, 4. And so the length here would be 4. If I'm over here, and let's say this is, 1/2 or something, I would just plug that in here, and so you would have 1/2 plus 1, so 3/2 would be the length of the line. I think if I did that right, 2 times, so that'd be, 1/4, divided by 2 plus 1. So yeah, that'd be like 3/2 would be the length of this line here. So it's always going to be, just you take your x, whatever your value of x is, and you plug it in here, and that's going to be the length of this line corresponding to whatever value of x you're looking at here. Okay, so it's just the y coordinate at every point. And so now the next thing we need, because we have to find the hypotenuse, right? So that's this. And so in order to do that, we're going to need to know what this adjacent side is, right? Because we're going to use the Pythagorean theorem. So the hypotenuse is the square root of the opposite side squared plus the adjacent side squared. Okay, and so what is this adjacent side? Well, remember, this would be x, say. Let me clean this up a bit. Okay, so like this would be our x here, right? And so this length here is just going to be 2 minus that x. And so the adjacent side as a function of x is just 2 minus x. And so now we can put that in here to write the hypotenuse as a function of x. So that's going to be the square root. Let me get rid of all this. It's going to be the square root of the opposite squared. So that's 2x squared plus 1. 2x squared plus 1 squared. Square that whole thing. Plus the adjacent side squared. That's this part here. Right? So that's 2 minus x squared. So that's the hypotenuse. And so now we have the opposite and we have the hypotenuse, and so we can write down what the sine of these angles are going to be, so that we're pretty much going to have the sine now as a function of x. And so we take the opposite, that's 2x squared plus 1, over the hypotenuse, which is all this here. So we have 2x squared plus 1 squared plus 2 minus x squared. Okay. And so, of course, so we want, theta as a function of x. So now we have sine of theta as a function of x, and so the obvious thing to do is just to take the inverse function. And so theta as a function of x is just going to be the inverse sine of 2x squared plus 1 over the square root of 2x squared plus 1 quantity squared plus 2 minus x squared. And so that's the function we were looking for, right? And so you can test it then to make sure it works. And so one obvious point to test it that would be easy is just when x is equal to 2, because that's just, we can tell right away that's going to be a 90-degree angle, right? And so when we plug in x equals 2 into this function, we should get a 90-degree angle. And so let's see if it works. Hopefully it does. Otherwise we made a mistake and we have to go back and fix this function. And so when x equals 2, so you have 2 times, this will be 4, so that's 8 plus 1 is 9, right? So theta at x equals 2 is going to be equal to the inverse sine of 9 over the square root of, okay, so we're going to have, okay, well, first off, when you plug in 2 here, right, this is going to be 0, right? 2 minus x, that's going to be 0, so that term's going to be gone. You're going to have, in this term, you're going to have 9 squared. So that's 81, right? So you have 81. So you have the inverse sine of 9 over the square root of 81, which is just the inverse sine, because the square root of 81 is 9, right? So this is just 9 over 9, which is the inverse sine of 1. And so what angle has a sine of 1? And that's 90 degrees, right? So it's a 90-degree angle, or pi over 2 radians, or whatever. And so it works, so the function works. At least for that point. I'm sure it probably works for the others too. I can test any other points, but that should be convincing that the function actually works.